Welcome to Vidyotma Physics. In next few minutes, I am going to explain you 5 key properties of electric field lines. First, I will briefly explain what is an electric field. Then we will discuss how to determine direction of electric field. Then how its field strength is related to closeness or distance spacing of an electric field line. Then why don't electric field lines form closed loop? After that, what is an uniform and non-uniform electric field? And finally, what are electric field line behavior inside a conductor? So let us discuss. First, what exactly I mean by electric field. See, you know about Faraday. Actually, he was interested to study about interaction of charges, that how these charges interact with themselves. You know that unlike charges attract, so they are attracting each other. But Faraday was interested in more fundamental question, that what is the cause of this attraction? Okay, sir, you will say, sir, Coulomb force, but what is cause of that Coulomb force? So what he coined one special term, that there is electric field. It is an imaginary concept given by Michael Faraday. Okay, so electric field is responsible for a production of electric force, which we call Coulomb force. So what I am saying is, this electric field is a cause and force is a impact. Sir, I am not getting, sir. I will explain. Suppose you have crush on someone and that person suddenly comes in a class. What will happen? You will get butterflies, right? Now you are getting butterflies, that is force. The person which is coming there is charge, and the aura of that person is field. So whenever you are coming in the aura of that person, you are getting that experience or force. So what Faraday is saying is that whenever a charge, suppose this charge plus q is attracted by minus q. So actually plus q is getting in the aura of minus q, and it is experiencing a force whose magnitude is given by charge times electric field. Are you getting it? So another definition I can give, that electric field is nothing but force per unit charge. Generally this charge is a test charge, so that nature of the charges or their behavior is not changed. So in brief, we have discussed about electric field line. Because it is responsible for production of force, so it is also called as line of force. But from where the question will come in exam? It will come from the properties which we are going to discuss now. And the first fundamental property is that electric field behaves like a general society. What I mean? Positive people, sir, positive people are looking outward. They are always expressive. And negative people are inward. They are overthinking about so many things. That means in negative charge, electric field line will always be inside, and in positive charge, electric field line will always outside. So electric field line starts from positive and ends at negative. So these are isolated charges, but if they happen to interact with each other, then what will happen? Actually the field will be like this. Field will be like this, and this is the direction. I will show you here. You can see. See, this is positive and this is negative. So simply positive charge, the field is originating from positive, terminating at negative, originating from positive, terminating at negative. Here field lines are attracted towards each other. That's why you can find more density of electric field lines over here. By the way, here there is no field lines. Here electric field is 0. Why, sir? In between this, at some point electric field is 0. Why? Because repulsive nature is there. Are you getting it? And here you can see that electric field is inside, because it is a negatively spaced or negatively charged. Okay, how to determine direction? Okay, second property, that is the first property only. First, what we have seen, positive charge electric field outwards, negative charge electric field inward. Then how to determine direction? So simple. Suppose I have to determine direction at, let us say, point P and Q. So simply what I will do is, I will draw tangent at this point, this is one tangent and this is another tangent, and I will say this is electric field at point P and this is electric field at point Q. So draw tangents and stay happy. Okay, what next, sir? Very important point is that electric field has a unique direction. What is mean by unique? Unique means single direction. Single direction. How, sir? Here the two field lines are shown. Suppose this is first electric field line and this is another electric field lines. So here they are intersecting. Now if I draw tangent at this point, let me draw. This is tangent at this point and tangent at. So at a single point we are seeing two different directions. How this is possible? Not possible. That's why always remember, electric field lines never ever intersect. This is very important point. If you get this, then everything is fine. First, only what you need to understand is my charge. See, electric field lines is directly proportional to charge, magnitude of charge. What I mean, I will explain. Electric field lines, if they are more in number, that means charge is bigger. You tell me how many electric field lines are there? 1, 2, 3, 4, 5, 6, 7, 8. Here number of field lines is how much? 8. And here how many field lines are there? Don't calculate, I know how many it is. 16. So if I am saying, what I am saying is Q1, how many field lines, sir? 8. Q2, how many field lines? 16. So if I just divide Q1 by Q2, I will get 8 by 16, or I can say that Q2 is 2 times Q1. Simple. Number of field lines is directly proportional to magnitude of charge. Are you getting it? Okay, sir. What next? Next is what? Suppose I take an imaginary area. What kind of area are you talking about? I will discuss. Wait. Let us say this is one area. Okay, and another circle if you take, this is another circle, sir. Okay, sir. Now if this is point number 1 and if this is point number 2, simply what you have to understand is, see what I have written, number of field lines per unit area is directly proportional to electric field. Okay, here it should not be charge, electric field. What I am saying is, if area is more, if field lines are same and area is more, then electric field is less. If you don't understand, simply know that closer the field lines are, more is the magnitude of electric field intensity. You tell me, at this point electric field lines are closer or at second point? Sir, at first point. Therefore I will say electric field at first is greater than electric field at second. So what you understand from this slide? Number 1, number of electric field lines is directly proportional to charge, and number 2, more closed the electric field lines are, higher its magnitude. So I will write here, where to write? Here I will write, where to write? More closed lines, then electric field is higher. Simple, simple, sir. Okay, sir. What next? Have you ever seen electric field forming closed loop? No, sir, we have not even seen electric field only. See, electric field never ever form closed loop. Why, sir? Because they are conservative in nature. What is meaning of conservative? Conservative means work energy theorem. Yes, conservative means what? Work done in a closed loop must be equal to 0. Or I can say that means delta Ke must be equal to 0. Work energy theorem, simply. If, and you know, by the way, electric field is a conservative in nature. That means work done in a closed loop must be equal to 0. But if it forms closed loop, then work done cannot be 0. You know friction? In friction, in a closed path, what is the work done? Is it 0 or non-zero? It is non-zero, right? Because friction is a non-conservative force. Here, electric field is what? Conservative in nature. Therefore, for work done in a closed path to be equal to 0, it cannot form closed loop. That's what I'm saying. Are you getting it? You should remember. Very good. What next? What is called as, sir, this uniform and non-uniform electric field? Simple. When I say uniform, Uniform, only two things you have to remember. One, magnitude, and second, direction. These two things must be constant. If it is constant, then it is a uniform electric field. If it is not constant, it's a non-uniform electric field. You tell me, is this uniform electric field or non-uniform electric field? Absolutely, sir, this is a non-uniform electric field. Why? Because if I take 2 points, let us say this is E1 and E2. Just now we have discussed E1 is greater than E2. Here, this is called as a perfect example of uniform electric field. Why, sir? Why uniform? Because you tell me which, here all lines are equidistant. You tell me, are they spaced closely afterwards or before? No, sir, it is uniform. That means electric field, if I take this point and if I take another point, let us say this is E1 and this is E2, I will say E1 is equal to E2. Sir, is direction also same? Yes, magnitude and direction is same. That means what? This is a uniform electric field. This is an example of uniform. And this is example of what? Non-uniform. Are you getting it? By the way, this field line is created by what? Sir, this field line is created by infinite plane sheet. Are yes or no? Electrostatic basic, come on. What next? Very important, very important. How electric field behave inside a conductor. See, one basic property of conductor is that it is equipotential. Equipotential means what, sir? On its surface everywhere or entire in body of conductor also, potential is what? Same. So what happens is, before that property, let us discuss first this property. What happens is, whenever electric field, I will take dark marker, okay. So E is external electric field, okay. So what happens when E external electric field is created? That external field applies a force on electron. Now electric field is towards right, that means force on electron, negative charge will be towards left. So all electrons are deposited over here. Conductor has so many electrons, so electrons are deposited over here. Here is deficiency, that's why plus charge is created. And what happens is, due to this plus and minus combination, there is internal electric field created E dash, and movement of electron, the electrons keep on depositing until and unless this E dash is equal to E. Are you getting it? Because when E dash is equal to E, at that time E net, okay, inside I am talking about, what is it? 0. If it is 0, then there will be no further movement of electron or electrostatic condition is there. So always remember, under electrostatic condition, here I have written electric field inside, net electric field inside conductor is what? 0. Always, okay. So I was talking about equipotential surface, okay. What? When the potential is equipotential, you know what is, okay. Do you know this formula? Delta V is equal to integration of, line integral of what? E dot dr. This formula you know, right? In electrostatics, you must have learned this. Now, equipotential means what? Equipotential means delta V is equal to 0. When delta V is equal to 0, when this term must be equal to 0. Sir, if this term is equal to 0, either electric field is 0, outside electric field is anyway not 0. So I can say that this is equal to 0 when dot product is 0, when theta is equal to what? 90 degree. Are you getting it? So because of equipotential property of a metal surface, electric field lines are perpendicular to the surface. So if I draw tangent here, I can see 90 degree angle. Here also if I draw tangent, I can see 90 degree angle. Suppose in exam, many times what they do, so this is a conductor and they draw like this. This is an absolutely false. Why false, sir? Sir, inside the electric field is not there. Then why you are saying false? Yes, inside electric field is not there. That way they are correct. But these lines must bend. Because always remember, electric field lines are perpendicular to the surface of conductor. So conductor only two property. First, under electrostatic conditions, electric field inside conductor is 0. And second, what is second property? 90-degree angle it makes with the surface. Now, with all properties done, you need to test yourself. This is a diagram showing electric field lines. Okay, you have to tell me which of the following is correct. Comment in the answers.